Let's take a look at this molecule. We're still looking to identify the parent system. And there are a couple of candidates here. We've got a 5-membered ring, but we also have a 6-membered ring. And this 6-carbon sequence is the longest sequence of carbons in the molecule. So it's a parent ring. For 6, we say hex. For a ring, we say cyclo. So we have cyclohexane. Next, we need to give the location of the functional groups that are attached to the parent ring. With rings, there's a way of double-checking this. What we do is we look at every single carbon in turn, and we start with that carbon being carbon number 1. Then we number clockwise and anti-clockwise. Next, we move on to a new carbon. That carbon is given carbon number 1, and we number clockwise and anti-clockwise. We continue with all the carbons present. Now we can shorten this process because in a ring, one of the attached carbons that has a functional group must be carbon number 1. So if you're looking at a carbon on the ring without anything attached to it, that carbon is not carbon number 1. So we can eliminate a couple of possibilities here. So we have 3 substituents. Each one of them could be carbon number 1. What we now do is add up the totals. We're looking for the lowest total when all the position numbers are added together. What we have here for a lowest total is 1 plus 2 plus 4, which gives us 7. So from this double checking method, we can see that the carbon on the upper left-hand side should be carbon number 1. Let's go back to our old method and see if that fits. Remember, the old method said find the lowest number. Well, that's always going to be 1 because 1 has to have a substituent functional group on it. So we need to go to the next number. 2 of the possible cases have 2 as the next number. 1 has 3. So we can eliminate the one where the second number is 3. So we're looking at the second lowest number. We have 2 cases where that's 2. So we now need to look at the third lowest number. Finally, we see a choice. We're choosing between 4 and 5. 4 is lower than 5, so 4 wins. And lo and behold, it is again the upper left carbon. So this is the carbon that is given position number 1. We now go on to identify the names of the functional groups. We have isopropyl at position 1, ethyl at position 2, and cyclopentyl at position 3. So in naming this molecule, we place them in alphabetical order. We have 4 cyclopentyl, 2 ethyl, 1 isopropyl, cyclohexane.